everyone, I am Anjan and welcome to the 24th video tutorial of the Verilog course series. In this video, you will be getting to know how the parallel input serial output shift register will work and how to design a Verilog code for it. I am splitting this whole video of the parallel input serial output shift register into two parts, that is part 1, part 2. And in the part 1, that is this video, I am covering the pre-coding part and the coding part. Which will cover the how the circuit diagram functionality Verilog code will covers, and the post coding part, that is part 2 of this video, will be going to be the on the tool, that is Vivado tool. We will be seeing the simulation and the synthesis on the part 2 of this video. If you also do check to that video too in the Shortcuts YouTube channel playlist. Let's move to the pre-coding part. In the pre-coding part, you will be seeing the circuit diagram and the functionality of the PISO shift register. And coming to the circuit diagram, there will be 4 D flip-flops connected to the same clock pulse given, and there will be majorly 4 inputs, that is B0, B1, B2, B3, and there will be a single output, that is Q3. And for running this circuit diagram, there will be a combination circuit, that is shift load bar combination circuit. There will be 2 conditions, that is shift condition and another is load condition, given to the these 3 flip-flops, that is 1, 2, 3 flip-flops through the same circuit diagram, that is 2 AND gates, 1 single OR gate. And coming to the working of this PISO shift register, you should know first the functionality of it so that you can understand in a better way. Coming to the functionality, if for an let's say I will use the pen for it to explain it. Let's say I am giving B0 as 0, B1 as 0 and B2 as 1, B3 as 0, and here is my output. My output will be like for every clock pulse there will be 1 output. Here I am giving 4 inputs, so there will be 4 outputs at 4 different clock pulses. At first clock pulse, that is at 5 nanoseconds, and second clock pulse, that is at 10 nanoseconds, at third clock pulse, that is 15 nanoseconds, at fourth clock pulse, that is 20 nanoseconds, at the first clock pulse I will be getting this B3 as an output, that is 0. At second clock pulse I will be getting B2 as my output, that is 1. At the third clock pulse I will be getting B1 as my output, that is 0. At the fourth clock pulse I will be getting this B0 as my output, that is 0. To get the parallel, to get a single bit, like if you are having a 4-bit value and you want to split that value into 4 single bit values, so you can do that by using 4 1 bits. Here I use comma so that it won't be look like 41. Okay. This is the functionality. Then coming to the question that how this will work to get this function, it will be using this condition like load condition and shift condition. As I said earlier, this coming to the load condition, it will dump these values, that is the inputs, to this D flip-flop to store those values. Like if this D flip-flop will be acting as like memory cells. In the load condition, we will be having 1 as 0 as the output, so that the load will become 1, and this load, when the load will become 1, this AND gate will be in active state and this AND gate will be in deactive state, and this OR gate will just drive the values of these AND gate inputs only. In the load condition, these inputs will be driven, and B1 will be driven to here, and B2 will be driven to here, and B3 will be driven to here, and B0 is simply given to the as an input. And in the shift condition, we will be given 0 as an input, so that this AND gate will be in active state and this AND gate will be in deactive state, so that it won't take any inputs further. And this shift condition, it will shift this value from this flip flop to this flip flop, and this one to this one, and this one to this one, and finally this from this flip flop we will be getting the output. Like at 5 nanoseconds we will be getting this 0, and after 5 nanoseconds, let's say another shift condition, this shift will become to here and this will become as an output here. Like this condition will pass on as the conditions. Let's move on to the coding part, so that you will be understanding coding of how my Verilog code is designed. And here I introduce the module name, that is shift register underscore PISO as my module name. You can use any of the your like, so that what you like you can name it. It's not matters anything, but you should not use 1, 2 any numerics in the as the first value of the module name, so that it won't get any errors. Coming to the port list, I use a clock, parallel, load, and serial out. This is my output, that is single bit output, and load is a single bit input, clock is a clock pulse, and parallel is the 4-bit input. And here I used a TMP register, that is 4-bit, to store these the values which I given. Like here you can see that say that you are using D flip flop to store the values, but to say to the Verilog code to store the values, I am using this TMP value variable to store the values. Let's move to the procedural block, that is always block. For every passage of clock, that is for every positive edge of clock, there will be one condition, like it will select if the load is in 1 or 0. If the load is 1, the input will be given to this TMP variable. If the TMP load is 0, this TMP will the third bit of this TMP will be given as an output, and using the concatenation and operator we are getting 0 in place of this third bit. These two operations will occur at the same time. And here I ended the module, and this is the end of the video. If you want to explore much more questions on Verilog, do check out the description box below. And if you like the video, do hit the like button, and subscribe to StarScratch YouTube channel, and check out the next part of this video on the post coding part. Thank you.